Morning guys. Today we are going to perform experiment FM demodulation using PLL phase lock loop. Okay, so just here again the board is transmitter board and the receiver board. Okay, so we are using FM demodulation PLL VCO loop. Okay, phase lock loop. Just make sure that the connection. So output is connected here to VCO, and VCO is connected to the FM demodulation part here, and capacitor output is connected to the low pass filter, and low pass filter is connected to the wire. Okay, so this is the connection. So what we have to do here is we will set the FM demodulator amplitude potentiometer to the far right. Amplitude potentiometer is at the right. Okay, F frequency potential, the carrier frequency FC is 10 kilohertz generated the frequency to 500 hertz. Okay, 500 hertz, and you peak to peak as 20 peak to peak, and export division. So let us see open the oscilloscope, set it to 500. Okay, so this is what the FM output, frequency modulated waveform. This we are going to transmit. Now we receive the signal here. Now take the output of the loop. This is the loop. Okay, take the output from the loop. First is take the output from the loop. Step 6, keeping expert division 1 millisecond and Y1 division 5 volt in spectrum analyzer. Okay, open the oscilloscope and make it how much? Expert division is 1 millisecond. 1 millisecond. Okay, and open the spectrum analyzer. This is curve Y1. This is curve Y1. This is the loop output. Okay, this is the loop output. So you can draw the signal here and the spectrum here. Okay, let me draw the signal and open the spectrum analyzer and make F max as 25 kilo, just to increase the range. Okay, 25 kilo. So take the single shot of this. Okay, you can draw this. Just write the frequencies respectively. This is how much? 0.5, 1.5, 0.51 and 1.5. Okay, let's just move it. Okay, you can just write the respective frequencies. Enough. Okay, so here we just draw the output of the loop from the oscilloscope and from the spectrum analyzer. Open the VCO output in step 6. Okay, so this is the VCO output. We'll connect to the channel Y2 here, and let us open Y2 here, make it Y2, take the output of the VCO. So here it is, VCO output, and go to the spectrum analyzer and take this image. This is the VCO output. Just write this and frequencies. This is enough. 7.5 and 6.5. Okay, this is the VCO output. And finally we will take the output from the low pass filter, because we want to remove the higher frequencies and get back our So let us go to the first thing. This is curve y1. We change it to curve. So this is our demodulated output waveform. This is the message signal we recovered, and this is the message frequency. Here it is one. How much we have given the frequency? 500 hertz. 0.5 kilohertz is 500 hertz. Okay, here we conclude our experiment, single sideband. Thanks for watching. Sorry brothers, we just left with the one thing. We have to take the output of isolation capacitor also. So isolation capacitor output is just we are connecting it. This is the input to the low pass filter, suppose. Okay, so let us take input to the low pass filter. We are connecting to the channel y2. Make it curve y2. So this is the output of isolation capacitor, input to the low pass filter. Okay, so this thing will pass through the low pass filter and you will get the output. Let us make it as a dual. So this is the blue one is the input to the low pass filter and black one is the output to the low pass filter. So let us make it again y2 and take the spectrum. Same thing you will get at 500 hertz. Okay, thanks for watching the video. Here we conclude our experiment, single sideband demodulation, SSB demodulation.